the resultant of a 20 Newton force acting to the right. Let's say this is the object. Okay. And you have two forces acting on it. One of them is the 20 newtons to the right, and you have the other one is 30 newtons to the left. So let's draw them. This is the 20 Newton force, and this is the 30 Newton force. Okay, I would take the right to be positive and the left to be negative. So the net force or the resultant force equals positive 20 plus negative 30. And the answer of the net force is going to be 20 plus negative 30 is negative 10. Negative 10 newtons, because you got it negative, it means it's to the left, because we just mentioned here that left is negative. So this is pointing to the left, this force. It's answer C, right? So answer C is 10 newtons to the left. Now we have a similar question, but we have it with east and west. East is positive, west is negative, west is negative. All right, so let me draw them. Uh, so a student is displacing, first of all, uh, with a displacement d1 towards the east by 12 meters, and then turns around and goes 6 meters due west, and then from that 6 meters continues west by 2 meters. So I can tell here that the net displacement is going to be positive 12 plus negative 6 plus negative 2. All of this is going to give me a net displacement of 12 minus 6 is 6. 6 minus 2 is 4. So 4 meters. Because it's positive, it means that this is due east. Okay, and do we have this option? Of course we have it. It's 4 meters east. Okay, next, chapter 5.1.6 and 5.1.9, those KPIs. Now, in order to solve those KPIs, we need to know a little bit of trigonometry and a little bit of components and vectors. So they're asking about finding the components of those two vectors p and x, p and q. So they want the component uh, px, qx, py, and qy. Now, always you have to know that um, here, when you have a vector pointing in the same direction as positive x, the angle is going to be theta, theta p is going to be 0. And the other theta here, theta q, is 150. Okay, you're gonna ask me, Mister, how did you know that it's 150? So first of all, let's get another color. Let me show you that this total angle here is nothing but 180. All right. So this whole entire angle is 180 minus this little angle here, which is 30. So 180 minus 30 is nothing but 150 degrees. Always we have to pick our angle from the positive x side, which is here, this positive x side. From here, I have to start with my angle, with my direction. So Let's carry on. The x component is always with cosine, so it's going to be p cosine. So you have the p here, it's 25. So 25 cosine 0. 25 cosine 0, if you do it on your calculator, please put your calculators on degrees, not on radians. It has to be on degrees so that you get the correct answer. So 25 cosine 0 is nothing but 25 newtons. Now, regarding py, it's to start with sine. So 25 sine 0, put it on the calculator, it's going to give you a 0 newton. Now, regarding qx, q is again nothing but 20. So it's going to be 20 cosine the angle 150. Okay, if you put this on the calculator, it's going to give you negative 17.3 newtons. Just let me make sure if this answer is the right answer. It is the correct answer. And now let's find out how much is qy. So qy is again 20 sine 150, which is equal to 20 sine 150 is equal to 10 newtons. So this was it. Now we go to number 12. It has something to do with friction. It says that you have an object here which was being pulled with a force F along a rough surface. Rough surface means that we have a friction, but the object remained at rest. Remaining at rest means that there is zero velocity, there is zero acceleration. It means that net force along the x-axis is zero. Um, Now they're asking what type of frictional force acts on the object. Now net force equals to zero, F net x equals to zero means that here this force which is to the right has exactly an equal force but in the opposite direction. So it means that there is a force which is the frictional force. Let's use another color to differentiate. So this is the frictional force, and it has to be static because it remains at rest. It's not moving. So it means that there is a force minus the static friction equals to zero. So they are equal to each other actually. All right, so it's pointing to the left and it's static because there is no motion. We're going to be choosing this answer, this option, static to the left. Okay, next question is again about friction. It's asking us here that a box is at rest on the floor. Um, the mass of the box is 150 kgs. It's at rest, means that velocity is zero, acceleration is zero, net force along the x-axis is zero. We have the coefficient of static friction to is given. It's 0.3. They're asking how much is the maximum static friction. So there is a formula for the maximum static friction. It's mu s Fn. Okay. Uh, See, Fn here is equal to mg. The reason why they are equal to each other because the object is not accelerating up and down. So since the acceleration along the y-axis is zero, so it means that the net force along the y-axis is zero. So it means that the only two forces which are one up, the other one down, are equal to each other. They are canceling each other's effects. So I can actually here replace Fn by mg, mass times acceleration due to gravity, which is equal to 0.3 multiplied by 150 kgs. multiplied by 10. Now, all of this, if you do it, 150 times 10 is 1,500. And then times 3 is 4,500. And then because you have a 0 point, which means that you are dividing by 10, so the answer must be 450 newtons. Let's just make sure about that. So again, 10 times 0 0.3 is 3. 3 times 150 is 450 newtons. So that's correct. Now the next one is if you exert a 35 Newton force horizontally while pushing a 15 kg box across the floor at a constant velocity. Again, velocity is constant. So whenever the velocity is constant, it means that acceleration is zero. So this means that the net force along the x-axis is zero. So if the net force along the x-axis is zero, that means that the force of friction, which is in this case kinetic because it's moving, it's a kinetic friction, would be equal to the applied force. But of course, it's in the opposite direction. So this is F, K. Force of friction, but kinetic. Force of friction is nothing but mu K Fn equals to F. Again here, the only two forces which are acting vertically on the box are Fn and mg. And they are equal to each other because the object is not accelerating along the y-axis. It means that along the y-axis, the net force is 0. So AY is 0. This means that F net Y is 0. So this means that Fn and mg are equal to each other. So this is Fn, this is mg, this is the force of friction, which is kinetic, and the force of friction, the kinetic force of friction, is equal to the applied force, just for the reason that we have here a constant velocity. So since v is constant, the acceleration along the x-axis is 0. So it means that the net force along the x-axis is 0. And that's why we are equating Fk and F together. So mu k Fn equals to F. And mu k is how much we have no clue. We are finding it. So mu k multiplied by mg equals to F. So mu k multiplied by 15 times 10 equals to 35. 15 times 10 is 150. So you divide both sides by 150. Mu k will be 35 divided by 150. This gives you 0.23 almost. So that's the answer. It's B. Now we go to